100 million miles beyond Mars, in the cold loneliness where no man had yet traveled, Deep Space Monitor 79 drifted slowly among the tangled orbits of the asteroids. For 3 years it had fulfilled its mission flawlessly, a tribute to the American scientists who had designed it, the British engineers who had built it, the Russian technicians who had launched it. A delicate spiderweb of antennas sampled the passing waves of radio noise, the ceaseless crackle and hiss of what Pascal, in a far simpler age, had naively called the silence of infinite space. Radiation detectors noted and analyzed incoming cosmic rays from the galaxy and points beyond. Neutron and X-ray telescopes kept watch on strange stars that no human eye would ever see. Magnetometers observed the gusts and hurricanes of the solar winds as the sun breathed million-mile-an-hour blasts of tenuous plasma into the faces of its circling children. All these things, and many others, were patiently noted by Deep Space Monitor 79 and recorded in its crystalline memory. One of its antennas, by now unconsidered miracles of electronics, was always aimed at a point never far from the sun. Every few months its distant target could have been seen, had there been any eye here to watch, as a bright star with a close, fainter companion, but most of the time it was lost in the solar glare. To that far-off planet Earth, every 24 hours, the monitor would send the information it had patiently garnered, packed neatly into one 5-minute pulse. About a quarter of an hour later, traveling at the speed of light, that pulse would reach its destination. The machines whose duty it was would be waiting for it. They would amplify and record the signal and add it to the thousands of miles of magnetic tape now stored in the vaults of the World Space Centers at Washington, Moscow, and Canberra. Since the first satellites had orbited, almost 50 years earlier, trillions and quadrillions of pulses of information had been pouring down from space to be stored against the day when they might contribute to the advance of knowledge. Only a minute fraction of all this raw material would ever be processed, but there was no way of telling what observations some scientist might wish to consult 10 or 50 or 100 years from now. So everything had to be kept on file, stacked in endless air-conditioned galleries, triplicated at the 3 centers against the possibility of accidental loss. It was part of the real treasure of mankind, more valuable than all the gold locked uselessly away in bank vaults. And now Deep Space Monitor 79 had noted something strange, a faint yet unmistakable disturbance rippling across the solar system, and quite unlike any natural phenomenon it had ever observed in the past. Automatically, it recorded the direction, the time, the intensity. In a few hours it would pass the information to Earth. As, also, would Orbiter M15, circling Mars twice a day, and High-Inclination Probe 21 climbing slowly above the plane of the ecliptic, and even Artificial Comet 5, heading out into the cold wastes beyond Pluto along an orbit whose far point it would not reach for 1,000 years, all noted the peculiar burst of energy that had disturbed their instruments, all, in due course, reported back automatically to the memory stores on distant Earth. The computers might never have perceived the connection between 4 peculiar sets of signals from space probes on independent orbits millions of miles apart, but as soon as he glanced at his morning report, the radiation forecaster at Goddard knew that something strange had passed through the solar system during the last 24 hours. He had only part of its track, but when the computer projected it on the planet's situation board, it was as clear and unmistakable as a vapor trail across a cloudless sky, or a single line of footprints over a field of virgin snow, some immaterial pattern of energy, throwing off a spray of radiation like the wake of a racing speedboat, had leaped from the face of the moon and was heading out toward the stars. The ship was still only 30 days from Earth, yet David Bowman sometimes found it hard to believe that he had ever known any other existence than the closed little world of Discovery. All his years of training, all his earlier missions to the Moon and Mars, seemed to belong to another man, in another life. Frank Poole admitted to the same feelings, and had sometimes jokingly regretted that the nearest psychiatrist was the better part of 100 million miles away. But this sense of isolation and estrangement was easy enough to understand, and certainly indicated no abnormality. In the 50 years since men had ventured into space, there had never been a mission quite like this. It had begun 5 years ago as Project Jupiter, the first manned round trip to the greatest of the planets. The ship was nearly ready for the 2-year voyage when, somewhat abruptly, the mission profile had been changed. Discovery would still go to Jupiter, but she would not stop there. She would not even slacken speed as she raced through the far-ranging Jovian satellite system. On the contrary, she would use the gravitational field of the giant world as a sling to cast her even farther from the sun. Like a comet, she would streak on across the outer reaches of the solar system to her ultimate goal, the ringed glory of Saturn. And she would never return. For Discovery, it would be a one-way trip, yet her crew had no intention of committing suicide. If all went well, they would be back on Earth within 7 years, 5 of which would pass like a flash in the dreamless sleep of hibernation while they awaited rescue by the still unbuilt Discovery 2. The word rescue was carefully avoided in all of the Astronautics Agency's statements and documents. It implied some failure of planning, and the approved jargon was reacquisition. If anything went really wrong, there would certainly be no hope of rescue, almost 1 billion miles from Earth. It was a calculated risk, like all voyages into the unknown. But half a century of research had proved that artificially induced human hibernation was perfectly safe, and it had opened up new possibilities in space travel. Not until this mission, however, had they been exploited to the utmost. The 3 members of the survey team, who would not be needed until the ship entered her final orbit around Saturn, would sleep through the entire outward flight. Tons of food and other expendables would thus be saved. Almost as important, the team would be fresh and alert, and not fatigued by the 10-month voyage when they went into action. Discovery would enter a parking orbit around Saturn, becoming a new moon of the giant planet. She would swing back and forth along a 2-million-mile ellipse that took her close to Saturn, and then across the orbits of all its major moons. They would have 100 days in which to map and study a world with 80 times the area of Earth, and surrounded by a retinue of at least 15 known satellites, one of them as large as the planet Mercury. There must be wonders enough here for centuries of study. The first expedition could only carry out a preliminary reconnaissance. All that it found would be radioed back to Earth. Even if the explorers never returned, their discoveries would not be lost. At the end of the 100 days, Discovery would close down. All the crew would go into hibernation. Only the essential systems would continue to operate, watched over by the ship's tireless electronic brain. She would continue to swing around Saturn, on an orbit now so well determined that men would know exactly where to look for her 1,000 years hence. But in only 5 years, according to present plans, Discovery 2 would come. Even if 6 or 7 or 8 years elapsed, her sleeping passengers would never know the difference.